the small button just below the one should go back. Yep.
Okay, cool. A wonderful piece of technology. Yes, it's very good. It has physical buttons after all. You don't get that easily these days. Okay. Hello, my name is Paweł. I came here from Poland. I'm a software engineer. It's lovely to see so many faces. Thank you for coming. Thank you for having me. Today we're going to talk a bit about effects, which is a topic from the functional programming. But don't be scared. You don't have to know the whole type theory to follow this presentation. Maybe one thing before we start, just to make sure that we're on the same page. When I say effect, I do not mean React use effect. I also don't mean effect.ts, which is a pretty big JavaScript library. Maybe it's a topic for some other day, but this presentation is not about that. And also don't mean side effects, okay?
Try pointing it down at the...
That does the trick. That does the trick after all. Okay, so the real question is, what is effect then? So there are multiple ways to answer this question, but I want to choose the simplest one. And for me, the simplest way to answer it is that effects are solutions that are coming from the functional programming world to the problems that we all have, okay? All of us, if you were coding today, if you were reviewing any pull request today, you had this problem, some of those problems already, okay? I'm not saying that effects are the only way to solve those problems. Quite contrary, imperative programming has ways to solve them. But I'm very vague, aren't I? Let's start by defining some of those problems. So all the code snippets here will be in TypeScript because, you know, TypeScript is what pays my bills. So get user by ID. This is a function that we want to implement in our API, okay? It's a function that takes a string. This string needs to be interpreted as an ID, and we want to return something. You know, question to the whole audience here, what it should return normally in TypeScript. What would you put in here? It's really an open question. Any ideas? The user type. Okay. Good idea. Okay. User or undefined. Okay, interesting. Good. Okay, this is a synchronous function, okay? Promise is a very good answer. This function is synchronous, so we don't need promise, although we could have promise here. I'm gonna go with user or null, although, you know, JavaScript has this special flavor here, this special sauce where we have null and undefined to basically signify the same thing, almost. But the imperative, traditional way of dealing with what? With absence of thing, because this is what we are trying to do here. We have, the first argument is an ID. It's any string. It can be ABC, it can be foo, it can be bar. So what we are doing, we are basically taking domain of all the possible strings and we are mapping it into two possible things. First, for some of those IDs, we're gonna return a user, yeah? That's okay, that's great. But not for all strings we're gonna have it. So here we are saying we are using either null or we are using undefined. Really, it doesn't matter as long as we are aligned on what it means. We are using null, so any other value to signify the fact that it just doesn't exist, okay? And it is weird when you think about it because it could be anything. Like, why aren't we returning, for example, a string saying, I don't have a user? Or any other thing. And I think the reason is that, first of all, it's a very old way of doing things. It comes from before JavaScript or TypeScript. And in 2019 and later on in 2020, we got special language constructs to make working with them easier. Think about it for a moment. We have a special language construct to deal with the fact that we have a traditional way of representing something. But let's change subject. Let us change subject and take another function that we have in our API. This time, it's yet another synchronous function in which we want to get all the users that we have in our system, okay? Very simple function that returns an array of users. The same user type, just an array. And here, it's the same story. When you're calling this function, you don't know how many users you're gonna get, right? It can be 1 user, 2 users, 3 users, 100 users, no users at all, okay? So we are mapping to an empty array with 1 element, and so on and so forth. And here, we have the same problem. Here we have the same problem, and we need special language constructs to deal with that, right? No. No, that's not the case here. When you think about it, it's super weird. For arrays, you do not need any special language constructs. You are basically more safe on the runtime because, let's face it, TypeScript is good, but you can always cast it. When you have something that is nullable, something that may be null, or something else, TypeScript will do its best to help you out if you are trying to do something nasty with it, but you can always cast it. And then in the runtime, you're gonna have bad times. But when you're gonna map over an empty array, what's gonna happen? Nothing. Also, please notice that the code in itself is a bit different. We say that this way of writing software favors composition over branching. Where branching, I mean, whenever there's a null, you have to make sure that it's not a null, and when it's not a null, you're gonna do some branch of code. You wanna execute it. So that's branching versus composition. Here you have one slide that shows you those two types of writing software, writing our code. On the left hand, we have absence, which is basically the effect we are trying to model here with imperative measures. And on the right hand, we have non-determinism, because that's what we are having here. Non-determinism in a way that you don't know how many results you're gonna get. It can be 1, it can be many, it can be none. That's the non-deterministic context here. So they two differs, and you can see it already. You look at this code and you know, okay, it's slightly different. And difference is that an array is an effect, and this is the effect I'm talking about here. And spoiler alert, I want to convince you that effects are worth your while. So, okay, are there any questions up until this point? If you have any questions, just let me know. I'm going to answer them as we go. So we touched on 2 effects or 2 abstractions that we want to model. So is there a way, now the question is there a way to model absence? So kind of replace this nullable with something that would have a similar properties as array that models non-determinism? And of course, answer is yes. Of course, the answer is yes, but the real question is how we can get there. In order to get there, unfortunately, we have to understand more about what the effect is on more like a general scale. So we say that the program is pure when it takes A and returns B, where A and B are pure values. You can think of it, okay, I have a function that takes a number and it returns a string. It takes a string and it returns a number. That's like the data that you want to have there. And this is what you're actually interested in, okay? Why are you interested only in the data? Because this is what we are doing as a software engineers. We take some input and we turn some output. Everything that happens in between is just transforming this data, right? A factful program is some function that takes pure data and returns it enveloped in this nice present. It wraps it for you, and what it wraps it for you is what we call an effect, okay? And this effect is some kind of a computational context for you. Depending on an effect and depending on what you're modeling, this context will mean different things, and you, fortunately or unfortunately, need to know and understand what this effect means and how to deal with that. So array is an effect of non-determinism, and if you use it, you need to know how to use it. But other than that, that's one of the incarnations of effects that you can have. So in this case, array is an effect, and the data that you care about, the real thing, the real deal is number. Questions?
Maybe one. So basically, when we have kind of data contact for JSON, when we retrieve data from API, and we have something like data field, which is an array of what we want to have users or whatever, and we have, for example, count or length property in the JSON, which kind of can return any data inside it, maybe users, maybe purchases, maybe whatever. But he has some service field like dates count, like result count. Either it's also a matter of this effect, or only array in this case.
Mm-hmm. Array can represent both data and non-determinism. Okay? Yeah. Like here, I chose this example, and I maybe should have said this before. But I decided not to because I didn't want to make it like more blurry. But with arrays, the problem is that sometimes it is just data. Yeah. And here in this case, I think, if I understood correctly, you're basically encoding some data and like transmitting it over the air.
The essence of my question was about array like a wrapper for numbers. And
Yeah.
for example, if you have in data context, or we have some wrapper,
Yeah.
which you present inside special field with our data, and has some special fields like data count, for example, length of result, and maybe error message. It is also nature of its effect. So that's such JSON content, which embeds under the hood everything.
I think the closest you get, because I'm gonna touch on this subject a bit later in the presentation. Not on this one. Like I'm not gonna go deep into every single effect, but you need to know there's like a whole dictionary of effects that functional programming over time they figured out how to do certain things. So the closest I can think of what you're describing is the reader monad, and by that effect. So we can talk after the talk about this one, about this particular one. I think that will be the closest.
Okay.
So it's like a different effect. It's still an effect. It has the same properties, like the whole thing, and I'm also gonna be talking about that in a moment. All those effects, they share the similar or almost the same API and functionality and a set of characteristics. So once you learn how to use one, you kind of learn all of them. But all of them, every single one of them, has a very specific purpose. I'm going to show it in an example. Okay? Let's get back to it after the talk. So moving on. If we wanted to model absence of data with an effect, Here we need to kind of ditch the idea of representing absence with a value, but we need to return a user. So given the previous slide, when you have something wrapping the data, in this case, our data is user. This is what we are interested in. We want to get our user. So it's kind of clear that it needs to be wrapped in something. And traditionally, we use name sum for it, or just in other functional programming languages. So the concept of existence of a user will be some user. The concept of non-existence will be usually called none. And in TypeScript, modeling that with option, that is sometimes in Haskell, it's called maybe. But other than that, I prefer name option. Option of user is either some user or none, okay? And you might be wondering now, okay, so what's the deal here? Like, it's a different way of writing the same thing. Like, where's the benefit of having all this additional abstraction? So the whole deal and the whole benefit of having this a little bit more abstraction is that this time, if you implement option properly, I'm going to show you how option works in practice in a moment. If you do it correctly, you get the same desired properties as you had with arrows. Yeah. So now you can basically benefit from this runtime safety because you don't have all those checks. You don't have to do all those checks. If something is none, you don't do this. It doesn't require any special language support. It doesn't require any chaining operations or anything like that, really. And additional benefit is that it favors composition over branching, which in itself may not sound like much, but once you get into this rabbit hole, you're going to start valuing it a lot because this is how it kind of rewires your brain into thinking with composition. Okay, but let's move on. Let's move on. Option of T is the solution, okay? I said at the beginning that effects are solutions to problems that every one of us have. So here the problem of modeling the absence, where you have all those if null, if not null, if undefined, if not undefined, is solved by the functional programming using and having this concept of option of T. Now, I'm going to show you it using the examples in the library called OKFP. This is a minimal library that you can try out even today that gives you the most useful minimum set of effects to be useful in daily life, to write your apps. The mission of this library is to, like I said, it's there to provide an essential set of effects that lets you use them in a way that is familiar to the TypeScript developers, not necessarily to the functional programming folks, but more TypeScript dev centered. Yeah, that's about right. First, we're going to define a helper function. This is a parse number. It's a very simple function that takes any string, and now instead of returning number or undefined, we're going to return an option of number. Okay, there's not much in here. The interesting part is this line. We need to take constructors. We need to import them from the library. Like those constructors will, as we call it, elevate those pure values into this wrapped context. Yeah, this is something that you will see over and over again when you get into functional programming and effectful programming, and you see it already with promises, for example, because spoiler, promise is effectful. It's not like full effect in the functional programming sense, but it's very close, yeah? And you've probably seen it many times where you already have constructors for promise, don't you? So here is the same. we take a pure value and we need something that will take it and put it into this wrapped present for us. Once you have it wrapped, you want to be there for some time. Like, that's your goal. You want to elevate this thing into this context and then process it. After you've done your processing, you want to get back on Earth and extract the pure data. That's the general strategy here. And for me, the strategy is to move to the next slide. Yeah, I do it. Did it. Okay. Okay, here's nothing much really. The positive function will just return some number when it's greater than 0. Okay, whatever. The interesting bit is the compute function. Okay, so what happens here is that we feed our input, that is a string, into parse number. The parse number function returns, this is the one from the previous slide, it returns an option, okay? And this is an interesting bit. What is an option? You don't know that if you haven't used this library. It's an object, and it defines a bunch of methods that may look familiar. It defines methods like filter, map, flat map, things that you would normally expect from an array to have, okay? So the next line is flat mapping over an absence, which sometimes is confusing, because how can you map or flat map over something that does or does not exist? And I need to admit, it took me a while also to wrap my head around this concept, but there is nothing special about mapping something that may or may not exist. The special thing is to understand that every effect has some unspoken rules. This is the part, you remember I said earlier in the talk that they share the same API. So once you learned one, you kind of know all of them, but every single one of them has this one special purpose. They abstract one thing. An option abstracts those branches with ifs. If you remember all those ifs that you wrote in your life, if you took it and compressed it into years of development, this is your option. This is this little box when you're sitting late in the night and writing those ifs into one place. So this functional programming basically takes that and puts it into box and says, you'll never have to think about it again. Trust me, bro. You're good. I have it for you. I got it. That's basically it. So every effect has this special power and special purpose that does it for you. Here, the key to understand mapping and flat mapping and filtering is that it has a preference over one value, because it can abstract, like it abstracts either having something or not having something. And it says, okay, when I'm mapping, when I'm filtering, I'm doing it over something that exists. When it doesn't exist, I don't care. So now this flat map is actually working on something that is already defined. When parse number returns something that does not exist, that is none, it will just completely ignore it. It will just shortcut it, short-circuit it, and say, okay, like I'm ignoring this flat map. The same will happen with map, where we are just multiplying it by 100. So if you run it with 4, it will return for 400. But if you run it with a number that is not positive, it will return you none. And the moment when it happens is here. So parse number will take 0. It will parse it as a number, sure, but then positive, when you're flat mapping it, it will say, okay, no, I'm not having that. I'm returning none. And then map will say, okay, it's none, so I have nothing to do here. I'm returning none.
Isn't it a bit let's say we are used that map is referencing usually a list of something,
Mhm.
and now the final result isn't a list of something. It's like, in this case, a number.
Mhm.
So like, isn't it some way contradictional to what we are used to?
I'm going to reverse this question. Isn't that, I don't want to use strong words here, but isn't that bad that we have only one of those effects in day-to-day usage? Because but the real answer to this question is that, yes.
Like, what if you have an empty collection? Like you just said, I mean, if you're mapping over an empty collection,
Okay.
right? You're not really mapping over anything. So it's the same thing again.
But I think the confusion here, like to me, because I feel this question, like I really do. For me, it was confusing to see something that I used only for lists, so arrays, and I see a method that is used on something that is not a list. That the confusion was for me when I was starting with this whole thing. And I was like, okay, like why are we using the same name? Couldn't we just name it some other way? But then it's functional programming. I would say that for me that's a flaw, but it's already got into a tradition, and we take this tradition and we respect it. So mapping is a very general mathematical operation here, and all those. Okay, I never wanted to, like, I had a goal to never say monad in the presentation, and I had a goal to never say applicative in the presentation. But, you know, once you get into the type theory, you can start see the beauty of it. I hope that you'll never have to. So for me, map and flat map, it's a compromise here. Like, we are giving a little nod to the tradition, and let's just keep it like that. Okay, so I wanted to raise one other case here. On the right-hand side, you have compute function written with OKFP functional way, and on the left-hand side, you have the same function that is written more or less using the same, like doing the same thing, but I would say that's like, it is an imperative approach in which you have parse number returning null or undefined, or a number positive does the same. Okay, and don't be afraid. I'm not trying to tell you that this is 100% better because it's only 4 lines. It's not about that. I mean, yes, that too. But when I was looking at the slide, I mean, I wanted to just let you know that it might be confusing why this is longer when this one is shorter. The fact that it is cool, but the real question is, where did all go, right? Like, is there anything that we are missing from the right-hand side, from the left-hand side? And the answer to this question and to like real understanding of this effect is basically that, like I said, all those ifs that you wrote late in the night through whole your life are compressed and abstracted into one neat, small abstraction. And this is why I like those effects, maybe. So all that you have here is already in the definition of the object returned from parse number, to be precise. Parse number will return an option that here is used as a type, but in OKFP it's both type and an object, two things. Parse number returns this object and has those methods in it, and within those methods you have these parts in some way. They are not ifs, but this logic is there. The conclusion that I wanted to end this presentation with is that effect data types, well, they are nice, they are cool, and they are, well, elegant. You may or may not like them, or you may or may not use them. But for me as an engineer, it would be good to know at least that that effect data types are basically there to control your flow of the computation. Those are tools that you may or may not use, and you are using it for controlling the flow of the computation. This is the name of the game. Before I end, I wanted to touch on yet another aspect of it. Okay, so why on earth I'm bringing up this topic, which is, well, effect data types are old. They are older than chaining operator in JavaScript, optional chaining operator in JavaScript. And my claim is that it's gonna be more and more important, functional programming in general, and the things that make your code smaller in the upcoming months and years. Let's take a look at what I showed here in the cute little neat table. Summing up, non-determinism, absence, okay, cool. We heard all about that. Absence in imperative mode is modeled by having nullable. And in functional, we have option. But there are other things that are affecting the flow of computation, like quite a lot. And they are very common, and you all know them. So you have an operation that may fail. For example, you're reading something from the file system, and it may crash. In imperative world, we are using exceptions, which are not great, okay? In functional world, we have either. When it comes to validation, which is different from failure, in a way that failure is modeling something that is a set of operations, and if one of them fails, you just want to scratch it. You don't care about the other steps because it's already done. With validation, you can imagine having a form with name, second name, VAT number, address, and whatnot, and you want to validate everything, and you want to present users with this nice array of errors. Here, in the imperative world, I don't know if there's any one prevailing pattern of doing that. It's just pure creativity at this point, because whenever I saw validation implemented in some way, whether it was backend or frontend, it was something either in-house or some library, and there is no one set pattern. Sometimes it's an array of objects, sometimes it's an object with properties that has array, it can be anything, really. And for asynchronous things, so yeah, we have a call, we get back, it may or may not fail. In JavaScript, in TypeScript, we have promises, which are not bad. As I said before, they are almost like effects. The difference between the natural way for the functional programming languages using task-either is that promise is eager, meaning as soon as you create it, it starts its work. Where task-either is lazy. Lazy is better because you can always get eager when you're lazy. You know what I mean. And the thing is that we already know that it's just not great. I'm not gonna get into why. It's not relevant. So effect data types are good, but good for whom? They are good for you, and I think we should start value things that are good for reviews, okay? If you catch my drift. I think that we're gonna be reviewing more and more code soon, because it's very easy to produce code these days. Now, we need to start value tools that will make those reviews easier. And when you look at this slide again here, there is appeal on having uniform APIs, right? There is an appeal in when I say when you learn one, you know all of them, right? And also those effects, what I really do like about them, if you start using those effects, you will notice it also, what they do to your code, you start focusing in your code more about those computations that matter. Yeah, I showed you the snippets of code left-hand side and the right-hand side. Yeah, and you saw that on the left-hand side you had those if this, if that. That's pure entropy. That's just something that you don't really care about. Of course, you care about that. You have to do it, but you do it because you have to, not because you want to. You care only about this stuff that is wrapped in this nice present, right? You want to unwrap the present. So those are good for you. But as I said, times are changing. And if you have already exposure to AI tools and especially agents, you probably noticed they really do like symmetries, right? They like to follow patterns. If you have a code base that is consistent, that has consistent patterns, whether it's front-end or back-end, they tend to produce better results. And my claim is that functional programming may have a resurgence now, soon, because even on the slide you can see it does provide symmetry. It's right there. And this will be valuable. So I'm saying and I'm claiming that those 2 points that we have at the end of this slide, so the uniform and predictable API where all the effects have map, or they all have flat map, they all have filter, and the fact they are cross-language universal, meaning, okay, in Haskell, option is called maybe, but, and some of the methods will be named differently, but they are the same. Like, they are literally doing the same things, they just named differently. Which means when you're using this way of coding, you're not only limited to this one language, to this one framework, you're opening yourself into more patterns that AI companies, they included in their models this way or another. We don't care how they included it, right? So yeah, OKFP, it's a library that if you wanted to try out this effectful way of controlling your computation flow, you can start here, look no further. It gives you what I consider a minimum set of effects to make itself useful. Yeah, shameless plug. And that's it. Thank you very much for listening, and I'm ready to take some more questions.
So, as you mentioned, that this type of approach you think has been before optional chaining. Maybe what's your take? Why hasn't it been included in the TypeScript standards until now?
I have no clue, really. When I started,
it doesn't break things, as I understand. It just adds to them. So
no, it doesn't break anything. And also, if you look at effect.ts, the library that I mentioned at the beginning, that this presentation is not about, but I'm gonna mention it again because it's the biggest. It's the biggest library right now, and there is this big move happening. The guy who wrote, I may butcher the name. It's TSFP or EFPTS. So basically, the biggest up-to-date, purely functional language for TypeScript. The guy is moving to effect.ts, and they're gonna be doing stuff together. So if you look at the page of TS, they even at the front page they say that this is the missing standard library for they want to be considered the missing standard library for TypeScript. So the answer to me is not clear why it happened, but it is interesting. When I started my journey as a software engineer, and it was there were times before TypeScript, I was told that JavaScript is a really functional language, isn't it? Because it has first-class functions, it has prototypal inheritance, and it was also like always, I was taught that this is a very functional approach. Then I went to Scala and I did some programming in Scala. I learned Haskell, which is a very good educational project, and I realized that programs written in Scala or in Haskell, they don't look the same. Haskell compared to Scala looks similar. Haskell compared to JavaScript, not so much. So what's the deal with this whole being functional programming? And effects is the answer, at least to me. Once I started using effects more and more, I realized, okay, this is what changes the flow, the way of thinking about programming. So why it's not there? No clue. Maybe because the TypeScript would have to, JavaScript will not do it. That's like, I can speculate. JavaScript will not do it, and TypeScript doesn't want to make too many runtime changes. They did it with enums, yeah, because enum will generate you an object whenever you use it. And do we consider enums like a greatest thing on earth? I do not. So imagine that, but multiplied by option, either, and so on. So maybe that. Yes?
You had it briefly in the third of the last slide. Yeah, this one. Regarding the exception handling, but does this somehow also change the approach how you should handle the exception? Or
Yeah, you don't use them.
The exception.
Yeah, the either monad here, this one. Remember this little story that I told you 5 minutes ago, that you take a constructor, you put it into this elevated state, you do some computations, some transformations, and then you get back on Earth, yeah? So the way to, every of those monad has a set of constructors to make it easy to basically interoperate with JavaScript, yeah? So with JavaScript, when you have exceptions, there are libraries that throw exceptions for you, like Axios, for example, yeah? It will throw an exception whenever there's a status that you defined or it's defined by default of the response. So here you have a nice constructor utility called try-catch that you have to wrap this promise into. Actually, you probably, for Axios that returns promises, you probably want to use task either. So that's the answer. You don't use exceptions in your own code, not anymore, because why would you? But if you have to operate on code that uses exception, you have ways to construct those values. The same goes for option. You have a provided constructor method that will make it easy to interoperate with things that return nullables. And it's called from nullable, if I remember correctly. So you have a function that returns something that is nullable. The from nullable constructor will take it and it will return an option for you. It's done like that.
I'm just wondering, I can see that the version is 0.2.2, so it's not a stable version?
No, it's not a stable version. It has all the, so it's a side project of a side project of mine, yeah? I started writing it because I was not fully satisfied with all the things happening out there. I didn't find the library that I wanted to have. And also there was this whole shift with TSFP. I think that's the name of the library, after all. And I decided, okay, I'm just gonna write it from scratch. It's not that hard, and it's not, like, really. This library is not meant to change the whole world. This is not a library that's gonna be your savior and will change the way you write code. Maybe it will, but it will be not because of the library, it's because those effects are awesome in essence. But yeah, it's not a stable version, although I consider it almost feature complete. So I mentioned that it's a side project of a side project because the first side project that I'm working on is considerably bigger, and I want to give it another couple months to marinate, and I'm using OKFP to, like, as a main tool to control flow. This is my main core library. So until I battle test it, until I prove it, it's not gonna be version 1, which means There might be API changes, breaking API changes in the minor version updates, but I have a changelog, so I think we're good on this side. But yes, it's not super stable. I would not recommend it. Maybe it's too early to put it into your main project at work, but feel free to use it. It should be okay. Who was first?
I'm wondering about one of the first examples about get users. How would you construct that one with option? Would it be option with users or an array with options?
Yeah. Answer to this question really depends on where you keep your users. Yeah. So it was I made a neat assumption, very convenient assumption that it's synchronous function. So that means I have it already in memory. Yeah. Let's say I have it in an array. And I'm just thinking now, do I have from array constructor? But if not, I would use from nullable constructor imported from the library and just find this user. So I have an array, I operate as an array. That's I think I had it on one of the slides that didn't make it to the presentation, that this library, one of the design goals is that it doesn't mean to and doesn't want to replace TypeScript. So array stays untouched, like you use array. You have TypeScript, you have JavaScript, you use all the tools that you have there. You have exceptions if you have to use them, but array will not, the library will not try to replace it. So if you have it in array, find it from array. If it's undefined, use from nullable, and that will return you an option. Yeah.
You say maybe you don't recommend using this like in production, but do you recommend reading it? How long is it?
Reading it?
Yeah.
Every monad is like, it's probably 200 lines, but most of it is documentation. So implementation of every function that you have there, so map, flat map, and so on, they're like 2 or 1-liners. AP is usually the longest. Yeah, applicatives are fun, but it's not terribly complicated. It's not. It's a very simple thing. So yes, you can read it. Yeah, of course. It's and also if you're interested in functional programming, it goes without saying, but especially these days where you can ask your friend, learning Haskell and just doing that as an exercise in learning how to think in a functional way, that's a good thing also. Like, I highly recommend it. Take your favorite agent, ask them away, maybe grab some book or some tutorial, and you're gonna have a wonderful time.
Biggest issue, I guess, is getting the teams to use it. And
Yeah, that's the big.
your colleagues and
Yeah.
because, one day my colleague would come and have a PR with your library, and
Yes.
I would not understand everything.
That's usually a challenge, and I think there's a book for that. And let's talk about the after the presentation. I maybe will dig it up.
I have a question. Why do you call them effects? Because usually those things are called monads.
Yeah. Yeah. You can call them monads. I specifically didn't want to call them monads, although in many places they are just called monads. But
yeah, I feel like the effects name is a bit confusing because effects are usually side effects.
Yeah. That's the whole deal. Like, I feel there is no good name for it, and I think there should be.
Maybe some sort of wrapper or context.
Wrapper would be good. So far, the favorite for me is not effect, like purely, but effect data types. It's a big like mouthful, but adding data type to it suggests that you are having kind of like, you're working on the data side, so you're wrapping something in something else. I prefer this one, but I specifically didn't want to call it monads because monad is just an implementation detail to me. You can have monads that have nothing to do with effects. Effects in this context are things that are solving the problems of controlling the flow of computation. That's what I meant. The name, I think, as the functional programming goes, it's a recurring problem, naming. They are not good with names.
Just for curiosity, have you tested like what's the overhead performance of all of these wrappers?
I was waiting for this question. I did not test the overall performance, so I didn't go and I didn't test it, but I knew this question will come, and my prepared answer is that it's okay. Trust me, bro. But yeah, seriously, if you think what it does, the overhead that you are getting is that whenever there's none, this part. If you take imperative example, you have two branches that you have to care about, and you have the one that, okay, like I have to do some computations when there's none, and then I have something where, okay, it's null, and I'm done. I just return. And in imperative world, you're getting bonus here for performance. You get extra points for performance, yeah? Where in the functional approach, every one of those functions, those maps and flat maps, will do this if for you. Where in imperative world, you can like early return. So this is the performance minus points for performance for imperative approach. But it's okay. I asked ChatGPT and it told me that it's okay. I'm kidding, yeah, but seriously, I should probably measure it, but it was such low on my priority list and I'm so sure about this thing, I wouldn't be concerned.
Let's ask Pawel.
Thank you.